Hello everyone. In last session we have already discussed about the project number 3. Now in this session we are going to discuss about the ladder programming for the project number 3. So here I have mentioned the addresses and the conditions so that we will get to know the idea while designing the ladder logic. Now let us start with the condition number 1. If any one input is on, only warning light should be turned. It means that we have 3 different inputs, and among these 3 inputs we just need to press only one input. So in order to execute this first condition, we have to connect the 3 different inputs in parallel, because if you are connecting 3 different inputs in series, so in that case we cannot able to execute the condition number 1. So simply use the run branch to connect 3 different inputs in parallel like this. So we can use the copy paste instruction also, so that it will reduce your time while designing the ladder logic or ladder diagram. Now here I am using one output coil. Okay, so basically if you have any idea about the logic gate, so simply you can observe these 3 parallel inputs. It means that here we are using the OR gate operation, because in OR gate operation we are connecting the inputs in parallel. So let us consider the switch A, switch B and switch C. Means if you want to write down the OR gate expression, that will be A plus B plus C. Now let us provide the addressing. Go to the data file and provide the address one by one like this. Just hold, drag, release, hold, drag, release. So here you can see the output is already in on state. Just make it 0, press enter. Now use one output. Here I am using, just a minute. Okay, here I am using this one. Okay, because here you can see in the data sheet we are using the O:2.0/1 for the warning light. That is the reason. You can select any random output address. Random is to say to which you are going to connect the warning light. Always remember. So if you want to provide the tag names, you can provide the tag name also. So for that, simply double click on I:1 and press the enter button on your keyboard and provide the description. So basically this is the start switch number 1. Start switch. Here I am giving the name start switch A. You copy, then click OK. And start switch B. You cannot provide the same tag name because it is not allowed in Alarm Value. If you are providing, it will not accept. Start switch C. Now provide the output address. Okay, now let us provide the description to the output address. Here this is the warning light. If you want to provide something else and something more about the output, so developer has provided the description window in which you can write down the detail which are related to the output like this. Okay, so in this way we have successfully designed the ladder diagram for the condition number 1. So basically this is the one program, but they have given 3 different conditions. So our task is to connect these 3 conditions to each other so that we can able to run this program properly. Now coming toward the condition number 2, as we have already discussed. In condition number 2, we have to press any 2 input. Okay, any 2. The input may be AB, switch BC and switch AC. Okay, any 2. So in order to execute this second condition, we have to use the 2 inputs in pair. Okay, it means we just need to create the pairs of these 3 given inputs. The pair may be switch A, switch B, switch B, switch C, and switch A, switch C. Right? So accordingly, we have to connect these 3 pairs in parallel, because if we are connecting these 3 pairs in series, so simply we cannot able to execute the logic. Okay, so we have only one option. We have to connect these 3 pairs in parallel only. So this is the way. Just like this. Just hold, drag, release the given address. It will save your time. Use the run branch, drag it on right side, drag this address, okay, properly, so that we can able to connect the rest of the pairs in parallel properly. Use copy paste instructions equally. Do not use the run branch instruction again and again. Switch A, switch B, then switch B, switch C, last one switch A and switch C. So these are the three pairs. And connect one output coil so that we can provide one more output address. So this is nothing but the alarm light. Alarm light. Okay, in the conditions they have given, only alarm light will be turned on. This means that when the alarm light is on, at that time warning light should be turned off. So in order to design such a logic, simply we have only one option. We just need to connect normally close contact of this alarm light in series with these three parallel inputs. Why? The reason is that when the alarm light gets on, at that time this normally closed contact will become open and it will cut the power supply, and accordingly the warning light will turn off automatically. So that is the reason we have to provide the normally closed contact of alarm light here. Now coming to the last number operation, if all three inputs are on, only fire warning light should be turned on. It means that we have to turn on all three switches at a time. So this is possible only when we are connecting the three different switches in series. It's very simple. The last condition is too simple, like this. Okay. Now connect the output coil and provide the output address. Here I am providing the output address, and the third number terminal of the PLC we have connected the fire warning light. Now simply provide the description so that you will get to know the meaning of that address. Fire warning light. Fire warning light. Again the same thing, when the fire warning light is on, at that time the rest of the two lights, means the alarm light and the warning light, should be turned on. So what we need to do, again the same process. Simply we have to provide normally close contact of fire warning light on second run as well as on first run also, so that when the operation of fire warning light is going on, at that time it will turn off rest of the two lights. So this is possible only when you are providing the normally close contact of fire warning light in these two runs. Means when the fire warning light is on, at that time this close contact will be open and it will cut the power supply for warning light as well as for the alarm light. It's very simple. Okay. Now this is the ladder logic for the project number 3. If you want to add something related, means the description for the each and every run, you can add it. Right? Means as per the logic gate, if you want to write down the equations or the expressions like AB plus BC plus AC, like this, you can put just for your understanding. But normally we are not providing too much description. This much of description is more than sufficient. Okay, now just verify the program. So why we need to verify? Because if you are verifying the program, we will get some error and we will get to know whether the given logic or the given or the design program right or wrong in terms of the ladder diagram code. Now just run the program. Do you want to go online? Click on S. Now we are in a remote programming mode. Run, so that we can go to the download mode. Here it is. You can see, as per the first condition, here I am pressing any one switch. Here I am pressing switch number 2. Now here you can observe the warning light is turned on and rest of the two lights are turned off. Now coming toward the condition number 2. Here we have already phrased the start switch B. Okay, so we have provided and we have repeated the start switch address too many places. So don't worry, we can repeat the address as per the ladder logic rule. We can repeat the input address so many times as per our requirement. It's mean that here you can see if you are considering these two input, this is wrong at all, right? So the inputs is same, or we can see this is the only one input which we have pressed now. Now we need to press one more so that we can able to execute the second condition. So here I am pressing the switch C because we have to press any two. See here I have pressed the switch C. Now accordingly the alarm light is turned on, and let us check what will be the status of rest of the two lights. Yes, the warning light is turned out. And same here, the fire warning light is also turned on. Means so we have successfully execute the logic for alarm light also. See, if you are pressing the switch A, then also you can observe the alarm light is working. If you are pressing the switch C, the switch A and switch C, then also you can observe the alarm light is working properly. Means you can press any random input. Okay. Now coming to the last number condition, here we have to press all three inputs. So we have already pressed the two inputs. We just need to press the middle one. Okay, in the start switch B, so that you can see the fire warning light is turned on now. Okay, because we have pressed all three inputs and power supply, and the current starts flowing through this run, and the fire warning light is turned on now. Now in this condition, we have to check the upper two lights also, means the alarm light as well as the warning light also. These two lights should be turned off. So as per the condition, these two lights are turned off. Okay, so this is how you have to design the program. Now here you can see the alarm light is turned on here, and that is the reason the normally closed contact of the fire warning light is open, and what it is doing, it cuts the power supply here also and here also. That is the reason we are not getting any response from warning light and the alarm light. So this is how you have to design the ladder logic for the project number 3. And if you want to add something additional in this project number 3 as per your understanding and as per your requirement, simply you can add. Okay, for any suggestion you can message me in question answer session, so that I will add some additional the project which are related to your suggestions. Thank you. Now